Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing the definition of an amplifier, classification of amplifier and a small example of an amplifier and its applications. Let us start with the definition. An amplifier, a circuit that increases the amplitude of a given input signal is an amplifier. So, see this block diagram of an amplifier. This is the input signal Vi versus t and the output signal is V0 versus t. So, a small AC signal is given to the input of the amplifier and at the output a large AC output signal is obtained. So, here only the amplitude is changed, the frequency remains the constant. So, what is written? A small AC signal fed to the amplifier is obtained as a large AC output signal of same frequency at the output. So, this is amplitude is small, here the amplitude is large, but the frequency will be same. So, we can define easily a circuit that increases the amplitude of a given input signal is an amplifier. So, amplifier constitutes an essential part in radio, television and other communication circuits. In digital circuits, BJTs and FETs are commonly used as amplifying elements. Coming to the classification of amplifiers, amplifiers can be classified based on the transistor configuration. Common emitter amplifier, common collector amplifier, common base amplifier. Based on active devices used as an amplifying element, they can be BJT amplifier or FET amplifier. BJT stands for bipolar junction transistor, FET stands for field effect transistor. Based on the number of stages, single stage amplifier, multi-stage amplifier. Based on the output, voltage amplifier or power amplifier. Based on the frequency response, AF amplifier, IF amplifier, RF amplifier. Based on the bandwidth, narrow band amplifier, wide band amplifier. Based on the Q point. So, there are 4 types: class A amplifier, class B amplifier, class AB amplifier, class C amplifier. After classification, let us see one example how an amplifier works. It is a common emitter mode because emitter is common to both input side and the output side. This is the emitter terminal which is grounded. We are giving an input signal of 5 millivolts and the output is observed at the collector point with respect to the ground, and the collector value RC resistor value is taken as 5 kilo ohms. So, here let us assume that an input of 5 millivolts is given, and due to this 5 millivolt signal an emitter current of 5 millimeter is flowing. Let us assume that 5 millimeter of emitter current is flowing, and we know the equation of IC. IC is equal to IE plus IB. IB is a base current which is very negligible. So, we can approximate IC approximated to IE. IE value is how much? 5 milliamperes. So, IC will be 5 milliamperes. So, IC is 5 milliamperes and RC is 5 kilo ohms. So, what is output voltage? I dot R. So, V0 is equal to IC dot RC. IC is 5 milliamperes, RC is 5 kilo ohms. So, 25 volts. So, output is coming how much? 25 volts. So, input how much we are given? 5 millivolts. At the output we are getting as 25 volts. So, this is how an amplifier works. It is a very small example taken over here. Let us see the applications of amplifier. Radio receivers amplify very weak signals until they are strong enough to make the sound audible. So, radio receivers use amplifiers to make the sound audible. Second, the transducers employed in medical and scientific investigation generate signals in micro or millivolt range which are incapable to operate the indicating instruments. So, these signals need amplification 1000 times to be strong enough to be indicated in a display device. So, we require amplifiers in amplifying the medical as well as scientific during earthquakes the seismic signals will be of very weak signals which are to be amplified so that they can be analyzed by visualizing them on a display device. So, these are the few applications of amplifier. I hope you have understood the class. If you have any queries, you can post them in the comment section. Thank you. Good luck, students.